Good evening and welcome to our live development stream for April 2021. First of all, sorry for not developing anything last month. It has been super busy for us. It still is, but it's getting a little bit easier now. And we're kind of back on track. So last month, you all voted for the projection X node, which essentially is supposed to unify the triplanar projection that we had as a plugin before, as well as the random textures projection, or the random tiling projection to be more precise, and basically wrap up all of the concepts that we have with the node editor now into something that's a bit more clean and more concise. So what I'm going to talk about today is how projections work in Lightwave, what projection X is going to do differently, how it's going to fit into the existing ecosystem of the db&w nodes, and afterwards maybe talk about the wheel rotation plugin a bit more and some other things. So yeah, let's move on. So what we have here is the usual Lightwave cow. This one is using PBR textures that are being triplanar projected. And if we go to the node tree for it, let's end the preview. Then what we see here is we have our surface, we have our principled BSDF, and we have our PBR texture set that has to have this mapping tab for the triplanar projection, which is enabled here, because otherwise it couldn't do that. And the problem is that essentially any node that we write that is supposed to support triplanar projection would need to do that within the node as opposed to having a separate projection node like Lightwave usually does. So it's basically duplicate code all the time. Plus, it also clutters up the user interface because you will always need this mapping thing. Ideally, none of this would be necessary. You would just see all of this and have an external projection node that creates a triplanar projection. And Lightwave does indeed have, as we all know, projection nodes. If I can actually find them, there we go. It's got the cubic, cylindrical, front, planar, spherical, and UV projections, which you can also use with this node. Some of the other nodes here that we have developed that would benefit from this would be something like the multi-image sampler. Even the random image mapper would be completely replaced by it because that would just be a projection. Texture repetition would be replaced by it. And some of the triplanar thing here wouldn't really be needed either. And to show you why, I will have to dig into the SDK and show you what's happening there if I can actually find the right file. Just a second. Just searching on the other display at the moment. Because there's so many files that are open or source files that I have to find one that actually uses it. Still searching, still searching. This one. so close. Yeah, sorry, that's not really well prepared, is it? But here we go. This should be. There we go. All right, let me just drag this over here. And let's see if I can increase the font size a bit. Yeah. So what we see here, this is basically the data that is being created by the projection nodes and sent to nodes that will use the projection to map a texture. Incidentally, this is also then sent over to a function provided by Lightwave that actually does return the texture value from an image texture using these parameters. What's important here is that we have a projection space, which is either local or world. That's this part. This is a transformation matrix. P is the position, either in world or in local, coordinates of the current spot that's being shaded. Or textured, and the important part here is the U and the V. This is essentially the texture coordinate that is going to be used. Now, the problem is if we look at something like a triplanar projection, let's go back to the cow here. What we basically have is we have a cubic projection. So depending on where the normal of the surface goes, it's either using the X, Y, or Z axis and to apply a planar projection of the texture. But the interesting thing about the triplanar projection is that at the angles where one direction moves over to another direction, for example, here we might have the X direction, here we have the Y direction, but at a place like this on the surface, it's kind of shifting from having a predominant X to having a predominant Y direction. That's where it starts to blend those two textures. Now, blending essentially means that we're evaluating for the X coordinate once, and then evaluating for the Y coordinate, which gives us two texture values, and then we mix them together. If you would want to express that intent of having two texture values blended together, you can't express that using the data structure that Lightwave uses because it only has one UV coordinate, which is enough for one direction, and it doesn't have a weight. So the idea for the projection X is to essentially use the vanilla nodal projection that Lightwave itself provides, but to extend that. And extending that means giving it the ability to store multiple UV coordinates with a respective weight attached to them as well. And if you then pass that to an image sampler, which would also be one that actually understands the new data structure, then that image sampler is going to say, all right, I don't have one UV coordinate to check to compute the texture values for, but I have multiple of them. So it's going to loop through them, change the UV coordinates, get the next pixel from the image, and then merges that with the result using a weight. And that basically allows you to add up multiple samples from the same image and weigh them with each other. That's exactly what's happening here at the parts where the triplanar blends. And that's also what's happening in the texture repetition node. Not sure if I still have some. There we go. The texture repetition node does the same thing because there's areas where the textures overlap each other, or that the single texture overlaps other parts of itself to create the notion of being seamless. And that's again the same situation. You have multiple UV coordinates for one spot that's being shaded, and those UV coordinates point at different parts of the same image, and they're blended together. And to express that kind of notion, this data structure just needs to be extended. Now, the downside is if I extend this, then only the db&w tools will be able to use them. But it also means that it makes the nodal networks a lot easier to create and to control. So, for example, the difference to this one, this is the node graph for this. Let me just, there we go, make it bigger. There we go. All right. So what we have here is we have a planar projection. Then we have the texture repetition node, and then we have a principled BSDF. And so this is the same for every surface. The interesting thing is with the new concept of the projection X nodes, what you would have here, you would have any kind of the native projection nodes, which could also be spherical, cubic, whatever. And the output of this would go into the new projection X node, or into a specific projection X node that, for example, takes the original projection but adds the texture repetition code to it, essentially. And the output of that would be a projection X, and that would in turn go into a image sampler X, which can deal with that new projection. If you instead would want to apply a triplanar mapping, then you would take a projection X for triplanar mapping and apply it to that same image sampler. So it kind of shifts the responsibility of creating the actual projections from a single node out into two dedicated nodes, and in turn gives you a generic node that can deal with all kinds of new and old projections. And in the case of a texture repetition node, for example, the texture repetition projection node will be able to add this kind of repetition to any kind of projection that comes in. And you can essentially, to a certain degree, mix and match them as well. And the texture sampler node in turn would almost be like the multi-image sampler, and it might as well just be the multi-image sampler. Except that it just allows for one image, but we could just strip it down and have a multi-image sampler with a new projection input, and then have a single image sampler that uses a new projection input as well. So it's taking existing code, kind of ripping it apart, and then eventually making it more logical and easier to use. Kind of the trick here is or was to get a decent concept to really simplify things in the end, and I think it will. It's probably harder to explain than it is to actually show once it's done. So yeah, that's the current plan. I'll probably get to start on that over the weekend. Probably by converting triplanar or something to a projection X node and then writing an image sampler for it, and then we'll just see where it goes. If you are on the Discord server, I'm certainly going to be sharing screenshots just so you see what's happening. And then we'll see how quickly I'll be able to send you a working build. So that's pretty much all I can say about the projection X at the moment. If you have any questions, feel free to type them in chat. I know there's some of you online just all being super quiet. And another thing I have been kind of working on, somebody sent me this test scene, and I can show it because it's just a wireframe at the moment, for a car with a fairly simple rig. I mean, you essentially have a wheel that's being attached to a car, and the car moves and aligns, and the wheel should just do its thing. And unfortunately, it kind of does. The rotation actually works the way it's supposed to. But the rotation just goes super, super wonky in certain cases. And this is better than it used to be, but I'm still on it. And somebody asked me what the tricky part about this is, and I can show you on a more simple scene. That's this one. And also this one still isn't quite where it should be. So the idea with the wheel rotation node was that it should cover as many use cases as possible. Oops. And that, for me, also includes driving backwards. So, you know, it rotates forwards, it aligns properly as well. But all of a sudden, this wheel stops here. And what's going to happen next is going to start rotating backwards. And all of the basic tutorials that you see for Lightwave or for other packages don't seem to take that case into account. Driving forward is easy, but stopping and then driving backwards and rotating accordingly and aligning accordingly is tricky. And the main problem for that is this point, and you can see that there's a flip here, which shouldn't happen. It's only for one frame. And that's basically where the start of the alignment of the wheel and the target for the wheel alignment, so the current position of the wheel and the position where it's going to be in, I don't know, a couple of seconds or frames, which is the direction it's pointing to, when those are basically on the different side of the direction change. And I'm still stuck on getting that to work. It's working fine here on that one side of the direction change, and then the direction flips and it's rotating backwards. It detects that it's rotating backwards because the alignment here is correct and the rotation is correct as well. But it's just that transition period where it's going completely bonkers. And that is something I still need to really suss out. That, yeah, I'm kind of wondering why it doesn't work, because I thought it would, but yeah, that's the trickiest part here. And also, one thing I noticed with the car example is that if, I'll just go back to that, this one, is that obviously the alignment of a wheel can't be computed by itself. So what it does now is it actually takes the parent alignment it looks at the parent alignment as well. So if the car rotates, then the wheel is going to rotate less or more, but it's going to adjust for that to reach its target. And in this case, the target is this knoll here, kind of. That's the target, or a target that's in front of the car. And you can see that the wheel is, damn, using the wrong shortcuts. You can see that the wheel is turning a little bit, but actually not that much. And it's just turning enough in relation to the rotated car. And let me just see if that works. Nope, don't want that. But I should be able to just rotate the car. Should be. Oh, it's aligning. Sorry, it's automatically aligning. That's why it's not rotating. But essentially, if you rotate the car itself, then this wheel will always move point in this direction, regardless of where the chassis of the car is rotated to. So it adjusts for the parent rotations. And that's something that it didn't do previously. This hasn't been released yet because I still want to find that issue for that flipping, that single frame there that you saw. Actually, there is a version on Discord for Windows, but yeah, I didn't want to release it yet before I actually find the last bit. But I'm getting closer, and yeah, this is surprisingly tricky. But hey, no pain, no gain, right? And yeah, if I would just leave out the alignment, it would just work perfectly. But you know, the idea of having it rotate forward and backward, I think, just makes it so much more useful. Especially if you go beyond just rigging cars, you know, there's other things with wheels, like, I don't know, gurney stretchers or whatever, that make use of something like that. Also, one thing that has happened that isn't that is in my current build, but actually hasn't been made or hasn't been released yet, but that will be a part of the next publicly released build, is somebody noted that the handles in the spline toolkit don't actually follow other items in world space. So if I go to the spline here and activate the spline edit, there we go, then you will notice that we have two handles here, and these are both set to follow another item. This one follows the item CP1, and one. Why don't you want to? Oh, I just need to, yeah. And the other one follows the item CP2. There we go. And previously it only used the local coordinates of the nulls. Now it's using the world coordinates. So if I take my CP1, which is in turn parented to, I think it's the master, exactly, and I move the master null here, then you will see that the control points also move accordingly now, even though the local coordinates of CP1 and CP2 haven't really changed, but the world coordinates have changed. And that should make it easier to create a spline that, you know, follows a set of nulls, so makes it easier to actually rig them. Yeah, that's again on Discord, and that should go live with the next update as well. And yeah, that's essentially the current state of things. A couple of head scratchers. I'm looking forward to the multi-project, the Projection X series, because that should make things a bit more streamlined, also streamlined to work with, and probably less complicated. Because currently with the nodal setups for texturing, we basically have nodes that don't just do one thing, but they do multiple things. And just to get back to that, actually, before I forget. All right, so I mean, one major motivation for that was, if you look at the PBR texture set, for this one I had to manually add triplanar mapping, because obviously once you have PBR textures, you would want triplanar mapping. Um, then a few months later, we all of a sudden had the texture repetition node. Now what we can't do is we can't use the PBR texture set with the texturing algorithm used by the texture repetition node. One way to do that would be to take all the user interface controls in here and add them in here as even more options. And if you look at the texture repetition node, this one actually has a section for triplanar mapping because we had to move the triplanar mapping in there as well. And the idea for the projection X is that we could get rid of the triplanar mapping tab here, we could get rid of the whole mapping tab here, and all of a sudden you could use the PBR texture set either with triplanar mapping or with the texture repetition node or with both in combination. And the same is true for the multi-image sampler, for example, um, which doesn't support texture repetition node or the PBR text or which doesn't support the texture repetition. It doesn't support triplanar either, so you have to manually set things up anyways in a very complicated way though. And yeah, so basically the idea is to kind of unify all of that and make it a lot easier and more consistent to use. Yeah, and that's pretty much all I have to say for now. Um, if you have any questions, please, yeah, I'm reading chat. And if you come up with things later, catch up on Discord. Make sure you join us on Discord as well, because we do tend to have a few exchanges and bouncing off ideas. And yeah, we do rely on your feedback anyways. So yeah, again, sorry for kind of skipping last month. We are catching up and regaining ground. Thanks to our patrons for supporting us. It is very much appreciated. Thanks to all of you for listening and watching. And yeah, I hope you have a nice evening and hopefully a nice weekend as well. So take care. Bye bye.